Hey guys, Anish PyMasters Scholars here. So today we have another problem. In this case, the problem is gonna involve queues. So the queue problem is going to be to reverse the first k elements in the queue. So for example, let's say that we had a queue where if it read front to back, it would read 1, 2, 3, 4, 5, where 1 is at the front of the queue and 5 is at the back of the queue. And we wanted to reverse the first k elements. In this case, k was equal to 3. So basically the resulting queue would look like this, 3, 2, 1, 4, 5, because the first k elements, or the first 3 elements in this case, are 1, 2, and 3. And then 1, 2, and 3 reversed would be in the order 3, 2, 1. And then we just maintain the relative order of all the other elements in the queue. So 4 and 5 would just stay in that same order. So we're just going to only reverse the first k elements in the queue. So we have to write a Python method in order to do that. Um, so the best way to solve this problem, there's multiple ways to solve this problem, but the best way to do it is we cannot modify these 3 elements in place because it's a queue. Queues, you cannot modify elements, you can only insert them, you can only add them to the end of the queue or remove them or access them from the front of the queue. So what we can do is we can somehow get these 3 elements, or the first k elements, to the back of the queue in reversed order. So instead of having 1, 2, and 3 out the front, we can take out 1, 2, and 3 and then add 3, 2, 1 to the back of the queue. So for example, let's say we had the queue 1, 2, 3, 4, 5, and then k was equal to 3. In that case, what we can do now is we can take the first k elements, and we can add them to the back of the queue in reversed order. So now the new queue would look like this. And the reason why is because if we just take the first k elements and add them to the back of the queue in their same order, so it'd be 4, 5, 1, 2, 3. In that case, we can't really do anything there because the point is to reverse those first 3 elements. So if we're able to get these 3 elements and add them to the back of the queue, because remember, we cannot modify the elements in place, it's a queue. We have to take the elements out and move them somewhere. So if we get these first 3 elements, add them to the back of the queue in reversed order, now what we can do is we can remove these first 2 elements right here, right, the first non-k elements, because these elements elements aren't the first k elements. We want the first k elements to be at the front, so we can take these 2 elements right here and move them back to the back of the queue, yeah, where they originally were. So take those 2 elements, and you'd have 3, 2, 1, 4, 5, and then that would be the final resulting queue, because 1, 2, 3 reverse, 3, 2, 1, and then keep the relative order 4, 5. So that is the best way to try to solve this problem. So in order to reverse the first 3 elements and add them to the back of the queue, or in order to add them to the back of the queue in reversed form, the best way is by using a stack, because remember, stacks follow the LIFO last in first out, where the last element we add into the stack is going to be the first one out. So if we add all 3 elements into a stack, the first 3 elements into a stack, and then remove all the elements in that stack and add them back into the queue, it's going to add them into the queue in reversed order. So if we take the first k elements, 1, 2, 3, add them to a stack, so this is what our stack would look like. We'd add 1, we add 1, and then we add 2, which would be the new top of our stack, and then we have 3, which is going to be the new top of our stack after we add 2. And then we take the stack and then add all the elements into the stack back into the queue. So when we remove these first 3 elements and add them into the stack, our queue would just have these 2 elements right here, 4 and 5. Now when we take out all 3 of these elements right here from the stack, we take them out top to bottom, obviously, because again, LIFO, last in first out. And then we would take the 3 out, we would take the 3 out first because it's at the top of the stack, add it, 3 is gone. We take the 2 out, add it back into the queue, 2 is gone, and then we take the 1, which is the only element left, add that back into the queue. And then now we just added those first k elements into the queue in reverse order. And then now our only job is to remove these first 2 elements right here, because remember, the k elements have to be at the front. remove these first three elements and then just add it to the back of the queue, which is easy because queues already follow the FIFO first in, first out. So just take the 4 out, add it back to the back, and then take the 5 out, add it to the back. And then that would be our final output. So now we can try to solve this in code. So remember, just for a sample input, we know that 1, 2, 3, 4, 5 should yield 3, 2, 1, 4, 5. So now we need to write a function. The function takes in a queue, which is going to be in the form of a deck. In this case, we're using Python. So reverse k should take in a queue. We'll call that queue just queue for now. And then it should also take in the parameter k, how many elements we have to reverse. Capitalize that because k is a constant. And then so now we'll just follow our logic. So we're going to need a stack. So we'll create a new stack. In Python, stacks are best implemented as a list. We're going to take out those first three elements, or the first k elements of the queue first. So for I in range k. And then take out those first or first k elements. And then q dot. And then remember, it's going to be in a deck, so we're going to use the append method. Sorry, stack dot append. We're going to add those elements into the stack. And then what we're going to add is just going to be whatever's at the front of the queue. So q dot pop left. So we're going to add the first k elements into the stack. And then now that we add the first k elements in the stack, now we can add those elements in the stack back into the queue. So while the stack isn't empty, so the length of the stack is greater than 0. So we're going to process each element in the stack. And then we're just going to add those elements back into the queue. So q dot append stack dot pop. So we're going to take the top element out, add that back into the queue, take the next top element, add that back into the queue. Then we keep doing that until the stack becomes empty. There's no more elements to add from the stack back into the queue. So now our queue should contain the first k elements at the end in reverse form. So we want to take out the first non-k elements now. So in order to take out the first non-k elements, what we can do is we could just loop from for I in range, and then we're going to loop from the length of the queue minus k. The length of the queue minus k should give us those first non-k elements that are currently in the queue that we need to remove and then add back to the end of the queue. So then we can just do q dot append for each of those non-k elements. Right. Just do q dot append and then q dot pop left. And then that should work. I'm pretty sure that should be it right there. So we can test this code. I'll create a queue right here, and the queue should just be equal to a deck. And then for the deck, we'll initialize it to 1, 2, 3, 4, 5. That's our test case. And then we'll just print. Well, we have to first call the method on the queue, so reverse first k on the queue, and then we'll just print the queue and see what changed. And then k will be equal to 3. And yep, it works. So 3, 2, 1, 4, 5. So obviously right here when we're printing the deck, it shows the deck first, and then it shows the deck, and then it shows like the list of elements inside of it. If you don't want that, then you can just define like a toString method, and then that toString method will just go through each element in the deck and then add that to a string, and then with that string, you can display or you can visualize the deck however you'd like. But if you just print the deck directly, it'll show you the deck and then the list of elements inside. It's not just going to show you a clean queue. So yeah, but that's the overall logic on how to solve this problem.